All right, so the first one, you're going to have some multiple choice questions on your test. If you look on those 3 practice tests, they're very similar to this. I'm going to give you a graph, and then I'm going to ask you to find left-sided limits, right-sided limits, general limits, or function values from the graph. So we'll go through these pretty quickly. These should be easy if you know what you're looking for. So this one is the general limit at 0. So you come up to the graph, and you approach x equals 0 from the left and right. That's what the general limit means. And it looks to be approaching the same y value, which is 1. So that's the answer right there, 1. Number 2, working straight across, the general limit at 1. So you got to look at both sides. So you find the vertical place where x is 1. If you approach 1 from the left, you're approaching the open circle at 1. If you approach 1 from the right, you're approaching the open circle at 2. And so in that case, because 1 doesn't equal 2, we know that the general limit is what? The general limit is DNE. Good. And we have a jump discontinuity when the 2 one-sided limits aren't the same. G of 2, that's going back to looking for the function value at 2. You look high, you look low, and you look for the dot, and it's right there at -2. So that's the answer to this one, -2. Number 4, the limit from the left of -1. The limit from the left of -1. So there's -1. You hop on the graph just to the left and start going back towards it. You're approaching the x-axis where the open circle is, and that's a y value of 0. So that one's 0. This one is the limit from the right-hand side of +1. Right-hand side of +1, we've already kind of done that one. That is going to be 2. It's approaching 2, where the open circle is. And then G of 1, we're back to looking for the function value. Wait, I did this one. Yeah, I'm sorry. I'm recording this and I messed up. This is me trying to go fast. G of 2, G of 2, G of 2. G of 2, here's 2 right here. So we're looking for the function value. And even though there's no dot there, you can assume that there is a dot there. So that one is 1. All right, now we'll go back to G of 1. G of 1 is looking for the dot. That's at -2, okay? So you just saw how easy it is to make a careless mistake when you're going too fast. But we're running out of time to go over this. So any questions on any of those? I'm hoping, unlike what I just did, those should be freebies, essentially, as long as you know what you're looking for. If you don't know what you're looking for, come see me. I'll be here tomorrow morning at 7 a.m. to go over stuff with you, okay? And we'll make sure that you know exactly what you're looking for the test. All right, this is what your quiz was going to look like yesterday. Find the domain, use proper notation. There's no radicals, but we have a denominator, and we know the denominator can't be equal. We then go towards factoring it, and it's going to factor into x plus or minus something. Once you set it not equal to 0, you need to keep it not equal to 0 as you work your way down. Factors of -8 that add up to +2, going to be +4 and -2. So the domain, d sub f, using the right notation, colon, the domain of the function f colon, it's going to be the set of all x such that x is not equal to -4 and +2. And of course, you can write it like that, or you can use interval notation, which is a little bit longer. You would then say parenthesis, -∞, -4, union, -4 to 2, union, and then you can go from 2 to infinity once you get past 2. So either one of those would work. Give the name and location of any discontinuity. Well, we know that there's 2 x values that interrupt the flow of the graph, -4 and 2. The graph lives on both sides of those, so those are discontinuities. They're either going to be holes or vertical asymptotes when they come from a rational function. So we do need to factor the top and bottom. So I'm going to come back up here. I know the bottom is x plus 4 and x minus 2. There's 2 ways to do this. You can just plug the -4 and the 2 into the top and see if they give you 0. Remember, if you get a 0 in the top and the bottom, it's a hole. But if you get a non-zero over 0, it's a VA. But if there is a hole, I'm going to make you find the y value. And so you're going to need to factor it anyway. So let's go ahead and just factor the top. It's got to be a 2x and an x. And now we're looking for factors of 12 that when we combine them with 5, or combine them with the factors of 2, we get 5. So did anybody find them? -3 and +4, that gives you a -12 product. That's good. And then you get a 8 on the outside, -3 is 5. So very good. You probably anticipate that one of the factors in the top is going to be one of the factors in the bottom. So you can kind of use that to help you. So the x plus 4's divide out. So the value that makes that 0, namely -4, is going to be a what? If they divide out, you can remove them. Then it's going to be a hole, right? Because that would cause 0 over 0. So we'll say that f has a hole, and you can use that word, at -4, comma, and then to figure out the y value, remember, we plug it into what's left. So if you plug your -4 into what's left, you're going to get a -8 minus 3 all over a -6, which is -11, -6, or positive 11/6. Positive 11/6. And that will probably get 2 checks tomorrow on the test. One for the x value, knowing it's a hole, and one for the y value. Then the other one that you cannot remove from the equation is the non-removable infinite discontinuity, also known as a VA. So then you'll say f has a VA, and notice how I'm writing in complete sentences. A VA at what? At 2? Would that receive credit? No. Yeah, at x equals 2. You would lose a point if you just put at 2. So make sure that you're very diligent. All right, any questions on part B? All right, we got 13 minutes left. I think we can make it. Now everyone's favorite graphs to hate, maybe. Maybe it's your favorite one to hate. That just means you haven't worked enough of them yet to love them. So the most important x values are -1 and +1. That's where the graph changes from one piece to another. Remember, the important thing is to figure out the y values where one starts and the other one stops. So direct substitution into the top, you're going to get a 3. So this one is going to be an open circle or a solid dot at -1, 3. It's an open circle, okay? And now I know that it's going to look like the graph of 3x squared. Well, 3x squared, the parabola, would normally come from way up here, go right through that point, and then bounce on the origin and go up. But we don't see it to the right of -1. So we're just going to see that much of it right there. All right, so it's going through some of my graph. That's okay. And then the next piece, I'll use a different flavor here. Now we're going to be the line between -1 and 1. Direct substitution, you get 2 minus 1, which is 1. So at -1, 1, we put a what? Solid or open? Solid. Okay, good. And then we want to know where it ends. You plug in a +1, you get 3. Is that solid or open? Open. You know it's a line. You only need 2 points to sketch a line. The y-intercept is 2. If you want to go a little bit more accurately, you can put the 2 there. But really, you're just connecting those points. And when I say points, I mean open circle or solid dot. So that takes care of the middle piece. And then we'll go with beefy brown for the right piece. To the right of 1, it's 3 over x. You plug in your 1, you get a 3. So it's a solid or an open circle at 1, 3. Open. Well, notice there's already an open circle there. So we'll just trace over it. And now the graph of 3 over x is going to be just like the graph of 1 over x. A quick review. 1 over x has a vertical and a horizontal, lives here and lives there. The 3 just stretches it vertically by a factor of 3, which we don't really show. So that graph is going to look something like that. It's going to approach the x-axis. And there's your function. That's what the graph looks like. Purdy, purdy, purdy. Okay? Now we can find the domain. The domain of g, that's the function's name. Well, you know it's going to go from -infinity. Every value from -infinity to -1 has a purple y value. And then at -1, we have a green y value, so that's good. Every value between -1 and 1 is going to have a green y value. That's good. And every value to the right of 1 is going to have a brown y value. The only one that's not in the domain is what? 1. Okay? Now, even though 3 over x had a vertical asymptote at 0 built in, we don't see it because we're only using that graph to the right of 1. So 1 is explicitly not defined. It's strictly less than and greater than. So the domain is going to be everything except 1. So the set of all x such that x is not 1. Or in interval notation, -infinity to 1, step over it, 1 to infinity. It can be fun to do that. So far, so good. Any questions? All right, give the name of any discontinuity and location. At -1, we have a what? A jump. So we'll say G, and notice the complete sentences. G has a, if you want to do it like this, with like a bullet point, G has a jump at x equals -1. And then there was one more. What type is this at 1? It's a hole. Good. And it has a hole at, anytime you're listing a removable point discontinuity or a hole, you have to list it as an ordered pair. So it'd be at 1 comma what? 3. Good. At 1 comma 3. Now, just for illustration purposes, let's say the function was defined to be 4. Would the hole still be at 1, 3, or would it now be at 1, 4? Still at 1, 3. Very good. The function value would now be 4, and it would be in the domain. So remember, the hole is the value where you're actually missing the point. And I hope you're not missing that point that I just made. Very good. Okay. That would have been your quiz yesterday, so hopefully everyone would have made 100 or 99 if they were 1 point apiece. All right. Now tomorrow's free response will look very similar to this. Okay? So let's see how to do these. This is going to be worth about 9 points on the back. So half of your test grade tomorrow is your ability to master questions like this. We'll probably even ask the same things. We're just going to change these functions to different numbers, okay? So it's kind of like do what I do and do it well, and you'll be fine tomorrow. Set up the equation for P of x equals G of h of x. Equation just means you have to have P of x equals. Some people don't put equations. They just set up expressions. So we're plugging the h function into the g function. So the g function is the square root of blob minus 8. And what are we plugging in for the blob? X squared plus 3x minus 10. So if you just have this right here, you think you're going to get credit? Is that an equation? No, that's an expression. You will lose points. So give it the name that I gave it. It's P of x. Now it says to find the domain. Well, you can simplify in this case without losing information. Negative 10 minus 8 is negative 18. So now to find the domain, remember you take the radicand and you say that it's what? Greater than or equal to 0. Can you solve that one algebraically? No, it's a quadratic. So let's factor it. That should be x plus 6, x minus 3 is greater than or equal to 0. What you can't do is set both of those greater than 0. But for our purposes, that's enough to get a x-intercept at negative 6 and an x-intercept at positive 3, and the parabola opens up. We want to know where it's positive. That's above the x-axis. So it's going to be everything to the left and at negative 6, and everything at 3 and to the right. So the domain of P is the set of all x, such that x is less than or equal to negative 6, or x is greater than or equal to 3. Remember, this is the disjoint interval. It's outside the x-intercept. There's no overlapping. So this is the one where you have to write two separate inequalities. You can't use the compound inequality. That's the AND case. It says do not doubly exclude any values. Okay, so for finding domains, do not doubly exclude any values. All right, part B, set up the equation for that. All right, let's do that too. R of x, we gave it a name. It's going to be 3x squared minus 4x minus 8. G of x is the square root of x minus 8. And it says to find the domain. Well, you have two options here. You could say that x minus 8 has to be greater than or equal to 0. That's the radicand. And then you would say for the denominator, the square root of x minus 8 can't be 0. Or you could just say x minus 8 has to be strictly greater than 0. We talked about that. But this will always work. So x has to be greater than or equal to 8. Pick a 9 to make sure that you didn't mess up. 9 minus 8 is positive 1. It works. Over here, you square both sides, and you get x minus 8 cannot equal 0. X cannot equal 8. So remember, since we squared both sides, you just want to check for extraneous solutions. When you plug in an 8, you get 8 minus 8 is 0. The square root of 0 is 0. That's good. We can't have a 0 in the denominator. So to combine the results without doubly excluding something, or to do it efficiently, we say it's the set of all x such that x is what? Greater than 8. Very good. The way that we omit the 8 is by taking away the equal sign on the inequality. We don't say greater than or equal to 8, comma, x cannot equal 8. That's like I like peas and carrots, but I don't like carrots. And if you wanted to use interval notation, it's kind of fun. Parentheses 8, comma, infinity. There you go. All right, moving right along. J of x. J of x is going to be f over h. So to set it up, the f function is 7 minus 3, radical negative 24 minus 4x. And h of x is x squared plus 3x minus 10. So we know that the denominator cannot be 0, and that's going to be x. What is that going to be? X. Does that factor right? H is, did I copy that down right? It's plus 3x minus 10. So what are the values that multiply to give you negative 10 that add up to 3? X plus 5, x minus 2, can't be 0. So x can't be negative 5, and x can't be 2. We're not going to doubly exclude any values, so keep that in mind. Now we look in the numerator and we have a radicand. So the work for the radicand, negative 24 minus 4x, has to be strictly greater than or equal to 0. Not strictly greater than 0. It can equal 0 because it's in the numerator. Now if we solve this, we get negative 4x is greater than or equal to 24. When you divide through by a negative number or multiply through by a negative number, don't forget to remember to what? Flip the inequality. Let's quickly test. I say something less than negative 6 works, like negative 7. If you do that, you get negative 24 plus 28, which is a positive number. So the domain of J is going to be the set of x such that x is less than or equal to negative 6. And then, do we need to even exclude either one of those in this case? Are either one of those less than negative 6? No. So they're already out. That's why I said don't doubly exclude any values. Okay? You only need to exclude the ones that cause 0 that are in the inequality. All right, and then the last one here, we're setting up the expression. So h of x of p, that's going to be x plus p squared. This is my favorite problem again. Plus 3 times x plus p. And then minus 10. There's the first term. And then the next term is just minus h of x itself, which is x squared plus 3x minus 10. And it's all over p. So make sure you keep putting it all over p. Now we expand it all out, right? Square, multiply, and double. Some people still aren't doubling it. Plus p squared plus 3x plus p, 3p, sorry, minus 10, minus x squared, minus 3x plus 10, all over p. This is your checkpoint. If you do it correctly, good things should happen. So make sure that they do. I've got an x squared, minus x squared, negative 3x, plus 3x, negative 10, positive 10. Everything that's left, this, and this, have a p. I do want you to factor out the p. Some people on the last test did not show the factoring out of the p. If you don't show this step right here, you're going to lose points this time. And then we end up with 2x plus p plus 3. And there it is. We went through the entire free response, and we have like 1 minute to spare. How about that? I'm going to post this online tonight. I know I went fast, but if you want to go back and watch the video, keep your quiz with you. I'm going to give everyone a free completion grade today. And make sure you can master, for sure, the back. All right, because that is going to be your free response question. I'll be here tomorrow at 7 again to go over things.